Welcome to Configuring ScreenOS Firewalls. This is the session on initial connectivity configuration and verification. So in this session we're going to go over what you would do with a device that's been factory reset or a device that's brand new onto your network. The objectives for this session are, when this is complete, you should be able to describe the functions performed by the different components of the ScreenOS operating system or device and understand their interrelationships. You should be able to select the user interface that you want to use based on all the options that you have available to you. And you should be able to connect to and establish connectivity to the device and set it up using the best practices for configuring the ScreenOS. Alright, so we'll begin here with system components. In the center of this image here we have the gray box. The gray box is representative of the ScreenOS hardware that you have just gotten for initial configuration. The red area shows the active running system. So this is all done out of RAM. In the RAM area, we will have our buffers that keep track of what's going on, like our session tables and the like. We will have a copy of the configuration that is used to run the device itself, and we will have the running copy of the ScreenOS software. The green arrow indicates that things are copied from the flash drive that is internal to the device, like it has your saved configuration and a disk copy of your ScreenOS image. These get copied from the flash into the running memory. Also on your flash are things like your certificates that you may have installed or other files of that nature. So it's a fairly simple computer type architecture, and underneath this ScreenOS is running on BSD kernel. On the left side of the device we have an indication that there will be interfaces. So most of the time this is going to be Ethernet interfaces that connect to your network, and you can configure them for those connections. Then we have things that are off on your network somewhere on the left-hand side. You can have a TFTP server if you want to be able to transfer files using that method from the ScreenOS device or to the ScreenOS device. You will have your DNS servers. If you're using syslog, you might have a syslog server. Web, SSH, and Telnet indicate that these are the different client services that can run on your client computers to connect to and manage the ScreenOS device itself. So you can use the web interface, you can use SSH or Telnet to use the command line interface across the network into the interfaces. NSM on the bottom is the product that Juniper offers for managing devices from a server product. You can buy an appliance that has NSM completely installed on it, Network Security Manager, or you can buy the software version of NSM, which can be installed then on Red Hat Enterprise Linux and manage your ScreenOS devices. So this is a central server-based platform that can manage multiple devices. We'll talk more about that a little later in the program. Finally, on the right-hand side of the image, we have a representation of the console port. There's a serial console port on the ScreenOS devices that can connect then to whatever computer you want, and you can manage the CLI directly on the ScreenOS device. Finally, there's this notation on the bottom here that says all the key system functions execute in RAM. An important thing to remember about ScreenOS is that when you connect to and edit the configuration on ScreenOS, you're working on the RAM configuration, which is the running configuration, what's actually being executed every time a packet arrives on the device. The saved configuration is not executed, but it is what loads when the ScreenOS device reboots. So you have to make sure that when you make changes, it gets saved from the running configuration to the saved configuration. If you're using the web UI, this will happen automatically when you submit. It'll update the running config and it'll save it. If you're using the CLI, at the end of your CLI session, you'll want to issue the save command to copy the running config into the flash drive for the save config. Alright, so your user interface options on ScreenOS. You have a number of choices to make here. There's a command line interface, CLI. You can access the command line interface using multiple methods. The console port that can be connected directly to a serial port on like a computer can be accessed for the CLI. You can use Telnet or SSH to connect to the ScreenOS device. Bear in mind that Telnet, of course, is passing credentials in the clear text across the network, so you do only want to enable Telnet and or use Telnet on secured internal networks that wouldn't be subject to packet sniffing for your passwords. Your second option to manage the device is using the web user interface. This can be accessed either HTTP port 80 or HTTPS port 443. The same caveat applies here to HTTP as to Telnet. That's an unsecured protocol. When you submit a web page using regular HTTP, the username and password will be in clear text. So again, you only want to enable that and use that across secure internal networks. You want to use HTTPS whenever possible. And finally, your management option here is to use Network and Security Manager. This is the server-based product that we mentioned in the previous slide, where you can manage multiple devices from a single server. This also collects logs and has a number of other features to make management of the devices a more unified experience across a multi-device network. Okay, so if we're using the CLI and we connect to the console port, there are a number of advantages that would come from this. You would have physical security, because in order to use the console port, you have to have physical access to the device. Likewise, this means if you have remote sites where the device is installed, you do want to make sure that the device is physically secure, because if people have physical access to the device, they can plug into the console port. No network is required to be able to use the console port. You don't have to have an IP configuration set up, and you can always get into the device regardless of the status of the network. You don't have to have an IP address configured, so if there's no IP address configured, this is pretty much your only bet to get into the device. When you're connected to the console port, you will be able to connect and see output even before the boot process, the power on process is complete. This is very useful when a device is experiencing issues during the boot process and does not complete. You'll be able to see what those messages are and understand what the issue is. When you're doing debug or snoop on the device, the output of these commands can be seen in real time on the console port instead of dumped and reviewed. And if you're establishing that connection, this is not configurable. So on the ScreenOS, you have to set to 9600 baud, 8 none and 1 as the connection parameters, and these end up being the default settings for a lot of programs that monitor the serial port anyway. So it's a fairly easy connection to make. Okay, on the CLI, when you first connect to the CLI, the default connection is to use the username NetScreen and the password of NetScreen. You will have the standard behaviors that you may be used to from VI or the other editors that are available in a Nix type environment. So your up down arrow keys will allow you to cycle through your command history. Control A, Control E advance you to those positions on the start or the end of the line. You can move around left and right. You can use the tab key to complete commands if they're partially typed. And you can use the question mark for auto-completion. So at any point on the command line, you can hit a question mark. It'll give you the available commands at that point. If you start typing a command, you can hit question mark to see what the correct completions of the next step of the command would be, so you don't have to remember. And also on the CLI, a lot of times you can, as long as you type enough of a command that it's unique, you can continue with the next part. So things like Ethernet 0/0 can be typed as ETH 0/0. They can be typed as E 0/0. So there are some shortcuts available in that regard too that you can experiment with on the command line. So a good place to start when you first log into the command line is to get the status information for the device using the get system command. When you type get system, this returns a lot of basic information about the device you've just connected to. You will get the serial number, the version of the software that's running, the operating system mode that's on the device. We can have transparent mode where we're operating at layer 2 as we mentioned in the earlier lesson, and we'll have a separate lesson just on that functionality, or we can have router NAT mode. You'll see the status of the interfaces of the device, and you'll see the management addresses and configuration that are on the device. So get system is a good place to start on a brand new device to see what the status is and where things are at. On the web user interface, when you first connect, you'll see this login screen. Again, the password is NetScreen. You, of course, have to have network access to be able to connect on the web UI. The web UI is HTTP or HTTPS, so it requires a working TCP/IP address and stack, and that you have a route to the device and all that fun stuff. The default address on a brand factory reset NetScreen is generally going to be 192.168.1.1, and so you would just put your computer into that subnet on the interface that you connect to the device on. If the device has been brand new or is factory reset, when you first connect, you will get the Rapid Deployment Wizard, which is a file you can generate using the NSM to import a configuration into a brand new device. So this is very helpful if you're sending devices. You can drop ship a brand new device to a remote location. You can create this file and send it to the person who is at that location, and then they can use it to upload your pre-configuration directly to the device. If you're not using NSM, you then have two other choices. You can just hit the next button on this and you'll go through the configuration wizard. The wizard will ask you some basic questions just to get the device up and running and set it up for your internal network segment so that you can get connectivity and have it come up on your network. Or you can just hit the cancel button here, and if you hit the cancel, you'll return to the general logon screen. You can log in and hack away directly on the exact configuration that you want to include on the device. Once you successfully log into the web UI, you'll be presented with the main screen. On this main screen of the web user interface, you see the output that's very similar to the information you get on get system. So this is always a good place to start when connecting. You can see the last few messages that are in the log on the bottom there. You can see the interface status in the middle. You get the serial number of the device, the operating firmware division, the type of hardware it is, etc. All laid out for you on that welcome page on the web UI. So this concludes our basic architecture for initial connectivity. Let's move on to the next section. All right, so now that we've got our brand new device and we can connect to it, let's see what we want to do to establish our initial connectivity on the network. We of course want to set up administrative access to the device. So in order to set up administrative access to the device, there's a number of steps involved. First, we need to set it up with an IP address that we can use on our network. So you're going to assign an IP address. You're going to select what management services you're going to use to connect to the device, whether you're going to use SSH, Telnet, HTTP, HTTPS, those sorts of things. And you're going to choose what IP address you are going to use to manage the device. So you have to assign the manage IP of the device can be different than the interface IP. You're going to change your initial root username and password. You obviously don't want to leave NetScreen on there, and you have the opportunity to change both the username and the password, and that is the recommended course of action. You can then create additional system logins if you want them. This initial root login has access to root level, all types of creation on the device. Later on, we're going to discuss the levels of admin access. You can create logins that have less access than root, but still have administrative access to the device. And then you're going to set your admin options on those functions. You'll configure the timeout values. You know, when you walk away from your logged in ScreenOS device as an administrator, you know, when will it time out? And you can also configure restriction lists, what ScreenOS calls the manager IP as opposed to the manage IP. Manager IP are either IP addresses or IP ranges that are allowed to connect to the device. So you can restrict to known certain subnets where you know your administrators operate from to be the only ones that can manage, even attempt to connect to manage the device. And then you're going to also enable any of the layer 1 and layer 2 configuration parameters that you need on your interfaces. So you'll go into your Ethernet and your serial interfaces, and you'll set the parameters that allow the negotiation of those interfaces to connect and actually work on your network where you're going to plug them in. So these are the steps that are required to set up access. Some of them are optional, but some of them are required, or it just simply won't work. A lot of times the default configurations will work for many of these options for you. Okay, so diving into the details here, we're going to start with what you're going to configure on interfaces. As we mentioned in the previous lesson, there's a hierarchical relationship, so you have to assign your interface to a zone as the first step in interface configuration. You can then define the IP address that interface is going to have as its address on the network. Then you're going to choose and secure the management options for that interface. So here's a pictorial representation of the relationship of the devices that we learned in the hierarchy. It is a hierarchical organization. The zone is assigned to a virtual router. the interface is assigned to the zone, and then the parameters are assigned to the interface. So you're going to assign the IP address, the management services, and other parameters to the interface itself. The interface belongs to the zone, and the zone to the virtual router. So starting with the zones, if you do a get zone, this tells you a default list of what's included as zone configurations on the device. There are several types of zones. The primary zone you're going to work with is a security zone. These are your normal transit zones. That's where traffic will come in and go out again across the device. Normal network traffic is all part of security zones. So, the vast majority of the time, that's what you will be dealing with is security zones. There are tunnel zones that can be used optionally for the VPN tunnel interfaces. And then there are a whole bunch of functional zones. Functional zones are for a specific purpose only, not for transit traffic. The first functional zone there is null. Null is where interfaces exist if they have no configuration on them at all. Null is like the black hole. When an interface is in the null zone, no traffic goes anywhere. It just comes in and deep sixes. The management zone is the zone for traffic to manage the device itself. And this is not a transit zone then. It would be used if you're configuring features like out-of-band management. The HA stands for high availability. This is a zone that gets used for interfaces that talk to between two devices that are set up in a cluster, NSRP, Net Screen Redundancy Protocol. So the only time you'll use that zone is when you set up an NSRP cluster. The self zone is for traffic that is destined for the device itself. So that can be put into that is the zone self, and it will have certain rules applied to it. And finally, the VLAN zone is only used when you're setting up management in transparent mode or layer 2 mode. So the VLAN zone, not to be confused with subinterface VLANs across your network, is used as a management zone for the transparent mode device. So again, going back to the top of the list, virtually everything that you do day to day on a ScreenOS device, you're dealing with security zones. Okay, so we're going to configure the zone and interface. There are a number of parameters that we're going to deal with here. First, just the zone and the IP setup. So when you have a factory defaulted Soho type ScreenOS device, you're going to see some created security zones called Trust, Untrust, and DMZ. These are editable and deletable, so they are just user-defined zones that have been pre-defined for you, and they correspond to what their names would suggest. So the untrust zone is designed to be connected to the internet. The trust zone is your full internal network, and the DMZ zone is an in-between network where you could put servers that you're going to expose to the internet. These are just suggested parameters, initial configuration set up on the small office, mid-size office type devices, just to get you rolling. They can be modified, deleted, or used or not used. Everything else you want to do on the device, you're going to define the zone, and you're going to manually assign all the parameters that you want to it. For the IP address, obviously you need the address and the subnet, and that's pretty much all that is required to set up IP on an interface. So what does that look like? On the CLI, we use the set command. The set command is what puts a parameter into the device, and the unset command clears that parameter from the device. We're going to configure a interface to belong to a zone, so the keyword is interface, set interface, which interface, Ethernet 0/0, the zone untrust, so set interface ETH 0/0, zone untrust, set interface ETH 0/0, IP 1.1.1.1/30. Now with those two commands, we have assigned Ethernet 00 to the untrust zone with an IP address of 1.1.1.1/30. In the web UI, you will perform the same configuration by filling out a form, going into the network section under interfaces and hitting the edit button next to Ethernet 00. List is in parentheses there because on some of the devices you have to hit the list to expand your options under network. In others, you can go directly to the list of interfaces. So some you have to list it, and some you have to some you can go directly to it. That will present you with the form, and you can fill out the IP address and the zone and the pick list for the zone assignments. Okay, next we're going to configure administrator traffic. So these are the best practices in securing administrator traffic. It is recommended that you change both the username and the password so that NetScreen becomes the username that you prefer to use on your network and the secure password. Choose a strong password and all that fun stuff. You will define your administrator lockout period so that you can't just sit there and throw a dictionary at it. Usually that's configured for 3. If you set an incorrect password 3 times, then you have to wait a minute before you can try again. You can change those to whatever the security policy is on your network, the number of attempts and the time the account is locked. You can also, it is recommended you also define permitted IP addresses. This is known as manager IP in the ScreenOS device, and so that admin connections can only come from those addresses. And then you're also going to restrict your interfaces themselves. You can use manage IP so that the IP address that's used to manage the device does not have to be the same address as what is configured on the device. And you want to turn off services you're not going to use on your network. For instance, like Telnet and HTTP, which are passing passwords in the clear. It would generally be recommended you don't use those. And anything you won't use anyway, just turn it off so it's not available. And you can also, the recommendation also is to change the default ports. By default, Telnet, SSH, HTTP, and HTTPS are well-known ports on the because of the protocols that they are, and so therefore hackers know what they are and can try to scan for them and use them. So you can, in ScreenOS, push those to other ports so that you can connect on a random higher level port of your choosing, and only you and your network administrators would know what that port is. So these are the recommended procedures to secure administrative traffic on a ScreenOS device. To configure management services on the device, We will use again, these are at the interface level. So on the CLI, you're going to do set interface ETH0/0 manage ping manage SSL. You basically use the manage keyword and then the service that you want to allow manage traffic on. So that turns on ping responses and it turns on the HTTPS port 443 management option. If you use the manage keyword all by itself without specifying any service, then the CLI will enable every service on the device. That's a shortcut available to you. In the web UI, you again find this by choosing the edit option next to the interface that you're going to edit, and there's a section of the web UI there that gets displayed called service options, and here you would just check off the service options that you want to respond on this interface. These are the defaults that are available by zone in ScreenOS. So that trust zone that is pre-configured on the small, medium-sized enterprise devices has all of the services turned on. The DMZ zone, the interface only has ping enabled, so that you can't manage the device from the DMZ, but you can ping it to do basic connectivity testing. And in the untrust and any other zone that's available on the default device, it has nothing turned on. So there's no management ability at all on the internet-facing zone. Okay, so now we have our Manage IP option. Manage IP will give you a separate IP address specifically to manage the device that is different than the IP address that's on the interface itself. So this gets configured by using manage-IP as the keyword. Set interface ETH0/0 manage-IP 10.1.1.1. So 10.1.1.1 would not be the same IP address as the interface itself. In the web UI, this is again on that page of the parameters assigned to the interface, and it looks like this. Your interface address is in those top two boxes, your subnet and your mask, and your manage IP address can be set in the box below that. By default, the manage IP is the same as the interface IP, but they can be different. The main scenario where this will be different and has to be different is if you're running a high availability cluster where you have two devices that can fail over and cover for each other in a failure scenario. Then the interface IP will go back and forth between whichever device is currently active, and the passive device will not have that IP address on it. So you want to have then a separate IP address for each of the devices so that they can be managed even when they're offline and not actually passing the traffic in the cluster. But you can also change this on any device that you want in order to have an extra layer of security, as we mentioned in the best practices. So you can consume another IP address, use that as the manage IP address, and then most people, when they're scanning and looking at your network, they're going to see, that the device is at .1 or at the top of the subnet, whatever that is, and they're going to try to make their management connections to the interface, and it's just not possible to connect at all because you've set manage IP to be different than the interface. Your next setup that you're going to want to do on the device for the first time, so management and all is going to work, is you're going to need to set up a default route. This will be the routing entry for your upstream router. You're going to need to know the interface that router is connected to and the IP address of the gateway that's going to receive that traffic. So to configure your default route on the CLI, this is just a route, so we go set route 0.0.0.0/0, interface ETH0/0, gateway 1.1.1.1. So you tell it what interface is accepting your default traffic out of this device, and what gateway IP address it is, and then the IP address of 0.0.0.0/0 means everything that doesn't match another route in my system will be sent to this address. In the web UI, the default route is configured under network routing and destination routing. So you'll click the new button, which will present this form to fill out. So we'll, again, those same parameters, 0.0.0.0/0 as the IP address and mask of the route. We will select the gateway option, Ethernet 00 on the upstream address. In the web UI, you'll notice on the bottom there's that description. When you create routes, you can optionally put a description on them. And then routes, of course, have these other parameters available as well, to the metric and the preference that can be used to prioritize among routes that are otherwise the same. Those parameters are also settable in the CLI. You just keep adding keyword and value as you type. Okay, so who can administer a ScreenOS device? There are a limit of 20 users can be created on the device itself, but only 10 can be concurrently logged in. So obviously if multiple administrators are logged in at the same time, hopefully you're coordinating your activity and not fighting each other changing the same parameters, but you can all simultaneously log in, edit, and change at the same time, up to 10 users. The root administrator. The root administrator login, that NetScreen that you've changed earlier, can create other users. The root administrator also has the ability to set asset recovery options and can replace the entire configuration on the flash drive. So these are the special permissions that the root administrator has above all the other administrators. Asset recovery options we'll talk a little more detail later, but essentially this allows you to disable abilities to make global changes on the device if you want to secure it further. Those, of course, you want to be careful with using, because if you lose the root admin login, then you can't make changes to the device in certain areas. So be very careful about those, but those are strong security features without a backdoor other than the root login. You can have a vSys administrator. Now, as we mentioned, the service provider class objects can have multiple vSys in them in the architecture class. So you can designate an administrative login for the whole virtual system, and they can change anything in the virtual system, but they can't do these root functions for the device itself. You can create a read-write administrator. A read-write administrator will have the ability to set and unset parameters within the sphere that you've assigned to that administrator. And you can do a read-only administrator. The read-only administrator will get to use the get functions to see what's configured on the device, or page through the user interface on the web to see what the configuration is, but not actually make any changes to it. So this is what you would grant to people like your basic help desk who want to check on things for troubleshooting purposes, but you don't want them to make any changes on the device. You want them to go in there and see those connection sessions and logs, but not actually change the policies, for example. So there are roles that you can assign to users too. There's some default roles called audit, crypto, and security. The crypto role allows you to configure and monitor cryptographic data like certificates and things. The security role allows you to modify or monitor security functions, and the audit role allows you to look at logs and those sorts of things. So these roles can be assigned to a user, one role per user, to limit more what they can read and write or what they can read only, if you want to narrow down the scope of what that user can see. You can use external authentication in addition to the 20 built-in users that you have in the system. ScreenOS supports connecting to LDAP, Radius, TACAX Plus, or Secure ID. It will use the existing accounts then in that system, and this allows you then to overcome the 20 user limit, because the accounts are no longer maintained on the ScreenOS device. They're not 20 created accounts here, but they're the accounts you manage in your LDAP server. You can also then assign authentication failover and priority and fallback behaviors. So obviously, if your external authentication server is down, you might still want to be able to get into your devices. So you can say check external authentication first. If that fails, go to local, that sort of thing, and define this behavior. All right, so we've said multiple times one of the things you want to do is change your root login from NetScreen to something else. This is how you would do that. Set admin name, and instead of NetScreen, you will type in your new name. Set admin password and your new password. So this will change the root login then from NetScreen to whatever you put in for a new name and password. In the web configuration, you will find this in the admin section. Configuration, admin, administrators, and then you can edit the user that exists there already, because NetScreen's an existing user, and you will change the password and the username. You just change the username to something else. In this case here, it's just showing admin instead of NetScreen. You'll type the old password NetScreen and your new password twice. There's also a checkbox you have to select here to allow this to access via SSH. That's on by default. You can deny SSH login at the user level. So to create other administrators, you would set admin, user, new user, password, new password, and then privilege. Privilege tells it what they're allowed to do, and set admin, user, new user role will apply one of those roles we mentioned earlier if you want to assign a role to the user. So new user is free text. You can create John, J. Smith, whatever you want the new user to be. In the web UI, this is done in that same area, configuration, admin, administrators, and there's a new button, and it presents you then with the form to fill out. Is it a read-write, read-only? Does it have a role? Is it allowed to log in SSH? And you can also apply schedules to user accounts. So you can say this user is only allowed to log in during business hours, for example, or something of that nature. You can do some management options on the console port. So the default timeout is 10 minutes. You can disable, you can change that to whatever you want. You can disable setting is set to 0 so that it is enabled. You can disable the use of the console port. So if you have a ScreenOS device deployed to an unsecured area because it's a remote site, you can turn off console port access. On the CLI, to change the console timeout value from 10 minutes to whatever you want it to be, you would do set console timeout and then the number of minutes that you want the timeout to be. To disable the console port, you would be set console enable or disable if you have that unsecured area and you want to disable the console access. So management timeout can also be configured in for the other accesses. So you can set admin auth timeout in minutes. This will then apply to telnet, SSH, and web access separately from the console. In the web UI, you'll find this under configuration admin management. And then that'll bring up this interface here. So you can check off that you want to enable the web timeout and how many minutes you want it to be for. If you're using dial-in access on a modem port that's configured on your ScreenOS device, that can be handled separately. And then here's also then where you set your lock the administrator on failure for how many minutes. 1 minute is the default. You also then set your redirect here for HTTP to HTTPS if you want to force the use of secure protocol and turn on SSL. So if you don't redirect, whatever port you select under HTTP port will be where you connect. This is also in the web interface where you would change the port that you're accessing for the HTTP access. Okay, so how does the authentication process work? The first request will come in from the computer workstation to the ScreenOS device with credentials, asking for access to the device. So the NetScreen responds and says, give me your username and password. So if you hit the web interface or the telnet interface, it'll say, it'll give you the prompt back. You'll submit your username and password in this reply. Once the ScreenOS device has the username and password, it's going to authenticate that user and password either against the local database or send it off to your remote authentication server. And once it has the answer, if it's positive, it'll grant the access, and of course if the username and password doesn't match, it will not grant the access. So very straightforward, standard authentication process. There are lockout options that you can set to avoid dictionary attacks or multiple attempts to hack in and check for your password. Root administrators can configure these parameters, and only root administrators can configure these parameters. It prevents access during the lockout period, so your submission of a username and password while the account is locked is just totally ignored. And this is a protection against things like dictionary or repeated login attacks, trying to cycle through passwords and guess what the password is. The options that you can configure are the number of unsuccessful attempts before you lock, the default is 3, and the time that the lockout remains in effect, the default is 1. You will simply adjust these parameters to be whatever the security policy is for your network. So to configure these, you're going to set them on the CLI using set admin access attempts, and this will be the number of attempts, default is 3, set admin access lock on failure, and the number of minutes that it will be ignoring further attempts. The command clear admin lock username will, if you don't want to wait the 10 minutes, 30 minutes, or whatever you've configured the lock for on the user, you can override that lock by using this command and allow the login again. In the web UI, these are configured under configuration admin management, and when you bring that up, you can enable these lock parameters here in this screen we saw previously, the maximum number of attempts to log in and the logout period there in the middle, or the lockout period in the middle. All right, the next security parameter you have for authentication is this permitted IP addresses. These are the addresses that are permitted to connect to admin protocols. You can restrict admin access then to trusted subnets or down to specific hosts that administrators are allowed to connect from. You will define a list of permitted IP addresses or ranges in this area, and this will apply at the entire device level. So when you set up these addresses, they apply to all the vSYSs on your device. They're a device level parameter. How do we configure the permitted IP addresses? So on the command line interfaces, the keyword is manager-IP, set admin manager IP 1.1.1.1, set admin manager IP 1.1.1.1 255.255.255.248. That sets an address range. And then you enable it by saying set admin manager IP enforce. In the web UI, these are under configuration admin permitted IP. So you set your IPv4 range here and you add it as permitted IP. Management operations. So in order to connect to the device, you have to match the management destination address on the interface. You have to match your source address has to match the manager IP of a trusted source list, and you have to match an allowed service type and port configured on the device. So all three of these conditions have to be true before you're allowed to log into the device. And of course then, once all those three are true, you have to present a valid username and password credential. There are a number of interface options on the device. The interfaces Ethernet are the primary ones that you'll find on the ScreenOS devices. You can have WAN interfaces, you can have DSL interfaces, you can have wireless interfaces, and you can create VLAN sub interfaces. Any of these interfaces can enable the management features. So you get to pick and choose which of these features you're going to enable on the interface, depending on the kind of network that you've connected it to. How do we reset a configured device to factory default? There are two basic methods for reset, what we call the soft reset and the hard reset. The soft reset can be done on the console port, so you have to actually connect to the physical serial console port. If you use the serial number as both the username and the password, you can initiate a factory reset. This is frequently the simplest way to reset to factory defaults. On the CLI command, you can do an unset all. So if you know the current login to the device, you can log into the device on any management method that's supported on the device and do the unset all. A hard reset is using the pinhole on the back of the device with a confirm. This can be tricky to pull off because it's a two-step process. First, you have to hold in the button for 10 seconds and then release it and watch for the flashes to match a pattern, and then hit it a second time to confirm that you want a factory reset. If you're doing a pinhole reset, it's often simpler to have a console computer connected to the device, because then you can see the actual prompt that says please press a second time to reset the device. The KB article that describes the factory resets permission is on the class website, so you can review that process. The important thing to remember in this is that both of these methods can be turned off by the root administrator. This would be done typically if the device is in an unsecured location at a remote site. So you can unset admin device reset, which is the soft reset, and you can unset admin hardware reset, which is the pinhole button on the back. You do have to be very careful when you use these options, because once you've unset both of these options, you cannot do anything to factory reset this device if you don't have the root login. So you lose the root login and these two options are unset, you cannot change this parameter on the device, and you can only do what the logins you have permit you to do. You won't have the root login, so you can't change these back, and you won't be able to factory reset the device. Alright, so our next section, we're going to talk about how you verify that these configuration changes that we've just been reviewing have been made, and how you check on the configuration of the device in general. As we mentioned previously, get is the keyword that allows you to see the current configuration on the CLI for a number of commands. So get system we looked at earlier for checking the basic parameters on the system. Get zone will show you what zone level parameters are set up. Frequently you want to do this to check on things like the security options that are set at the zone level. Get interface you will probably use a lot to see what's happening in the configuration on your interface, the statistics on your interface, for troubleshooting. Get route will show you the basic route setups, and if you can also get routes to specific IP addresses to see where traffic will be sent based on the current routing table, and allows you to do troubleshooting that way as for routing issues. Get ARP will show you the current MAC table, MAC learning table that's on the device, so that you can troubleshoot things that may be happening at layer 2. Get admin will show you that those configuration changes you made on the administrator earlier are in place, and that they're here. And of course, our friendly question mark command will show you all of the options that you're able to view. You can also use that question mark command after any basic command here, like get route question mark or get interface question mark. Will show you possible completions to narrow that request to more specific parameters. So the question mark is definitely your friend when you're trying to figure out how something is currently configured in the get command. So this is the output of a specific interface, Ethernet 00 in this case. You can see if you just ask for a specific interface, you do get a lot of information back just from this single command. So when you have a connectivity problem coming through a particular interface, this gives you the quick overview of what that looks like. And you can verify that your IP address has been set correctly, and that your configuration that you thought you deployed is actually here. In the web UI, you verify your interface configuration in the same place you set it. So if you submitted and set that configuration, you can go right back into edit and confirm that everything's been set up as you wanted it to be. You can see the entire page here that we've been showing sections of before, and in one page it shows you the basic information that you would get from get interface Ethernet 00. And of course it's tabbed off for more specific information as it goes. To verify the administrators, if we say get admin user, that tells us the details of how that configuration of that user is set up. You can see this one's the admin user login here is a read-write login, and the NOC admin is a read-only user. And then you can see in get admin SSH tells us that they are enabled. All three of these users, NetScreen, which is our root login, admin, and NOC users, are enabled for SSH access. In the web UI, this is under configuration admin administrators, and you get, as you can see on the bottom there, a list of all your users. Tells you whether or not they're enabled and what privilege level they have in the column, and then you can go ahead and edit them or remove them at that point. If you need to verify the permitted IP address, you can do on the CLI get system, which system is a very long list of all the system parameters, and then we're going to use the pipe command, and you have INC is for include manager IP. So this will pipe in standard Unix pipe, which means it'll take the large output from get system and only show us the lines that contain manager IP. The quotation marks are there, of course, because there's a space between manager and IP to let the system know that that whole unit has to be there. In the web interface, you'll find this under configuration admin permitted IPs. You'll notice that these web interface locations are exactly the same place that you configured it. And it lists them on the middle of the page there. The configured management IPs in this case is this same one we set earlier in the slideshow. So to review, this lesson we've talked about just some basic configuration options to get you up and running on a factory default device. We've described the different system components and how the ScreenOS runs in RAM, loading from the flash. We described the options you have for connecting on the user interface via either the multiple connections for CLI or the 2 connections for the web or the console port, and when you would use each of those types of connections, and especially when you need to be careful with Telnet and HTTP, which passes passwords in clear text. We established our initial connectivity to the device, and we set up our administrators and our IP configurations and all the services necessary to be able to manage the device on our network. If you have any questions, you can either contact me directly via the course website if you have any questions about the material we've covered in this session, or you can go to the forum for the class on that device and post a public question so that everyone can see the questions and the answers. I thank you for your time and attention, and this brings us to the end of the initial configuration connectivity session for configuring ScreenOS devices.